Hello everyone, welcome to TechLogix. In today's tutorial, we're diving into an awesome Arduino project, building a system that captures IR remote signals and displays their hexadecimal codes on an 8-digit 7-segment display using the MAX7219 module and an ESP32. Whether you're a beginner or a seasoned maker, this project is fun, practical, and perfect for learning about IR communication and LED displays. Let's get started. Before we dive into this awesome Arduino project, let's go over the stuff you'll need to get started. First, you'll need an ESP32 or any Arduino-compatible microcontroller. This is the brain of our project. Next, grab a MAX7219 8-digit 7-segment display module. This is what shows the cool hexadecimal codes. You'll also need an IR receiver, like the TSOP1838, to catch those infrared signals from your remote. Don't forget to grab some jumper wires and a breadboard to connect everything neatly. Alternatively, you can use a PCB board to solder the components as demonstrated in the provided diagram. Finally, you'll need a computer with the Arduino IDE installed. Plus, we'll use two libraries, LED control for the display and iRemote for the IR receiver. I'll walk you through installing them in a bit. Check the description below for links to the libraries and the full code to make things super easy. Now, let's get started with the code. Head over to the video description, where you'll find a link to the complete Arduino sketch. Just download it and open it in your Arduino IDE. This code is already fully written and tested to match exactly what you saw in the demo video, so it should work right out of the box with the hardware we've set up. That said, if you want to tweak it, for example, to change the display brightness, adjust the pin assignments for a different microcontroller, or even add features like storing multiple IR codes, feel free to customize it to fit your specific needs. Before uploading the code, we need to install the two essential libraries that make this project possible, one for controlling the MAX7219 LED display and another for handling the IR remote signals. These libraries simplify all the complex communication protocols, so you don't have to write everything from scratch. To install them, open your Arduino IDE if it's not already running. Then, navigate to the top menu, click on Sketch, hover over Include Library, and select Manage Libraries. This opens the Library Manager, where you can easily search for and install libraries with just a few clicks. It's a straightforward process, and it ensures your code runs smoothly without any compatibility issues. In the Library Manager, first search for LED Control by Eberhard Fall. This library is specifically designed to control the MAX7219 module, allowing you to easily set digits, characters, and brightness on your 7-segment display. Select it from the results and click Install. Make sure to choose the latest stable version. Let's get the iRemote library set up to decode those IR signals from your remote. Start by searching for iRemote library on Google to find the official GitHub page. Look for the latest release by Armin Joachimsmeyer and download the zip file to your computer. In the Arduino IDE, go to Sketch, hover over Include Library, and select Add Zip Library. Then, choose the iRemote zip file to install the latest version quickly and easily. For an even simpler option, you can use the Arduino IDE's Library Manager to install iRemote. Just go to Sketch, Include Library, Manage Libraries, and type iRemote in the search bar. Find the version by Armin Joachimsmeyer, install the latest one, and close the manager. I chose to download the latest iRemote library from the GitHub page. After downloading the zip file, extract it to your computer and copy the extracted folder to the Arduino libraries directory. You can usually find this folder in Documents, Arduino/Libraries. This ensures the latest iRemote version is ready for your project, making it super easy to decode IR signals for your Arduino setup. To configure your Arduino IDE for smooth communication with the ESP32 and MAX7219, start by opening the IDE. Go to Tools, then Board, and select your ESP32 board, like ESP32 Dev Module, from the list. Next, under Tools, click Port and choose the correct port your ESP32 is connected to, such as COM3 or /dev/ttyusb0. If you're unsure, check your computer's device manager or unplug and replug the board to identify it. If you see a fatal error, avr/pm H, when compiling your code, don't worry, it's an easy fix. Open the LED control library folder, usually found in Documents, Arduino/libraries/LED control. In the LED control CPP or LED control H file, look for the line hashtag include. Comment it out by adding // at the start of that line, then save the file. Now, try compiling your code again, and it should work smoothly with your ESP32. If you get an error with the iRemote library after installing, don't panic, it's a simple fix. When you extract the downloaded iRemote zip file, it often contains a subfolder like iRemote main. Move only the inner iRemote folder, which holds the library's content, to your Arduino libraries directory, typically Documents, Arduino/libraries. Ensure there's no extra subfolder nesting, so the IDE can find the library files correctly. Now, restart the Arduino IDE and compile your code again to get your project running smoothly. Once you've confirmed your code compiles without any errors in the Arduino IDE, hit the Upload button, usually the right arrow icon at the top. Make sure your ESP32 is connected to your computer via USB and the correct board and port are selected under the Tools menu. The IDE will compile the code again and transfer it to your ESP32. When the upload finishes, you'll see a success message, and your ESP32 will start running the code immediately. If you run into any issues during the upload, don't worry, it's usually an easy fix. Double-check that the correct port is selected in the Tools menu, as it might change if you unplug and replug your ESP32. Ensure your USB cable supports data transfer, not just power, as some cables can cause problems. Once the code is uploaded, your MAX7219 display and IR receiver should be ready to show those hex codes from your remote. Grab your IR remote, point it at the receiver, and watch the magic happen. The Arduino code is set up to show IR remote hex values on both the serial monitor and the MAX7219 display. First, ensure your serial monitor is set to 9600 baud rate to match the code settings. Connect your ESP32 to your computer, open the Arduino IDE, and launch the serial monitor from the Tools menu. Point your IR remote at the TSOP sensor and press a button to send a signal. You should see the hex code appear instantly on both the serial monitor and the MAX7219 display. Note that the MAX7219 can only display up to 8 characters of the hex value. If the IR code has more than 8 characters, the serial monitor will show the full value. The MAX7219 will trim it to the last 8 digits, keeping the display clean. Stay tuned for the next project in this series, where we'll use an LCD display instead. The LCD will support showing longer hex values for even more flexibility. For more details on downloading the wiring diagram and code, check the video description below. We've included links to everything you need to start this Arduino project. In our upcoming video series, we'll dive deeper with different ways to display hex codes. These videos will show you how to enhance your smart home setup. You'll learn to explore all the cool features of this project. If this video helped you, please give it a thumbs up and share it with others. Subscribing to TechLogix keeps you updated on our latest tutorials. Your support helps us create more awesome content for makers like you. Every like, share, or comment means a lot to us. Thanks for being part of our community, and see you next time.